Welcome to the Team Rōnin Hackathon project overview. We're excited to share our generative AI solution for this competition. Rōnin Consulting is based in Middle Tennessee and specializes in custom software development, helping companies build secure, scalable solutions that streamline their business. For this competition, we developed a generative AI solution to help medical staff save time when dealing with prior authorizations. But before we dive into the software, let's first take a look at the problem this solution addresses. Prior authorizations are a cost control measure, requiring physicians to obtain insurer approval before prescribed medications qualify for payment coverage. This process can delay patients from receiving treatments and burdens physician practices. The AMA recently surveyed over 1,000 physicians and found some compelling results. 88% of physicians describe the burden of prior authorizations as high or extremely high. The numbers speak for themselves. The current process is slow, inefficient, and costly. However, by leveraging the power of large language models, the time required to draft prior authorization letters can be significantly decreased. We wanted to build a tool medical staff could easily use to rapidly build letters with patient data and generative AI, so that patients could receive better care and faster access to treatment. Now let's take a look at the application and how it could be used to improve this process. We recommend maximizing the playback window size of this video for the next portion to improve the legibility of the text on screen. To begin our demo, let's imagine that you are a physician or staff member tasked with writing all the prior authorization letters needed for medications prescribed today. You will start by logging in. Since this is a healthcare solution, we've implemented several security features to ensure compliance with HIPAA requirements. You'll notice one of these right away. At the login screen, users must complete a multi-factor authentication by entering their credentials and a code sent to their mobile device. This solution is also designed to encrypt all data while in transit and at rest. Once logged in, users will be able to see a queue of patients and meds waiting for a prior authorization letter on the left side of the screen. This patient data comes from the synthetic mass database we deployed to Azure, simulating integration with an EHR. Clicking a patient card will initiate the generation of a letter. Behind the scenes, we are dynamically gathering the patient history and building the prompts required for the large language model to create the prior authorization letter. This process takes seconds, compared to the time needed to manually compile relevant patient history record by record from the EHR and complete a draft. In the right-hand panel, users have the option to edit or regenerate the letter. It is important for LLM-based solutions to include a human review to catch inherent bias or hallucination artifacts that may be generated. Saved letters can be used for further fine-tuning and improving the model or downloaded as needed. For our judging viewers, a behind-the-scenes button is also available, which reveals the prompt sent to the LLM. As a proof of concept, it is easy to see how the use of an LLM could simplify the generation process for providers and save time. The solution could easily be adapted to include denial response letters for even more time savings. Now, let's briefly review the technology being used for this project and some of the lessons we learned along the way. This application is designed as a single-page app written in React.js and is running in a Microsoft Azure environment. The synthetic mass database mentioned earlier is running on Azure SQL, and the large language model is running in AWS. The LLM is an open-source model based on Meta's Llama model that has been trained with additional clinical data just for this event. One of the challenges we encountered was dealing with the token count of the prompt needed to accomplish letter generation. Prompts of this size, combined with lengthy letter content, push the limits of the token caps available. Higher token volume can become costly on OpenAI, leading us to shift into using an open-source model with a fixed cost structure regardless of token volume. Our advice would be to carefully test and select the right model to ensure the output quality is satisfactory. To recap, our solution illustrates how an open-source large language model, trained on clinical data, can be used to generate high-quality prior authorization letters that are individually tailored for each patient. When combined with a well-designed UI to streamline the review, revision, and approval of the letters, providers can save time, accelerate the workflow, and in turn, enable patients to receive faster coverage approvals for their medications. We really hope you've enjoyed the video. This solution was developed by the team at Rōnin Consulting. We'd like to extend our appreciation to the event sponsors and a huge thank you to the judges for their time and consideration.